So we're back for solving the Geek for Geeks, day 49 or 50th. I don't know. I don't care. Just solving problems. And currently we are over with binary search tree problems of this week. We have already solved more than 7 to 8 problems of binary search tree, and it was an experience that binary search tree is not ending and ending. But again, we are back with a new set of problems. I guess this week will be all about strings and substrings. So today's problem statement is: if given a string and the string has a number, then the output will be the sum of the possible combinations of that number. You can see the sum is equals to 1 2 3 4. Is if the number is 1 2 3 4 stored in as string, the substrings can be 1 2 3 4 12. So these are substrings. Why it is called substring? Because a substring is a string which is formed inside a string. So 1 can be a substring, 2 and 3 and 4 12 23 34 123 234. These are all the possible values and possible combinations of this number, and together when we do the sum of these numbers, the sum adds up to as 1670. But also we need to remember one thing: we cannot take the reverse digits like 43 or 321 or 432, because the sum has to be in this order only, because the string cannot be reversed. Also, the answer will be really large sometimes, because it depends on the string and the length of the string. Suppose there is an s equals to 1234, over here it is 1234. What if it is a 6 digit string? Or so you can imagine, like, it will be the time complexity and space will be log to the power of n, and it will be really long. So in order to optimize the time and space complexity, our task is to only complete the function and take an s as argument and return the answer modulo 10 to the power 9 plus 7. So if you do modulo 10 to the power 9 plus 7, we are like giving an optimized answer. So let's go with the code over here. If you haven't seen my channel before, go like, share, and subscribe to this channel. It has all the E for Geek set of curated problem statements of the day. And let's start. First, static long, so it has a long return type. So first take the value of the modulo, which is 1 10 to the power 9 plus 7. I've calculated the modulus value over here. Then long, I have to take a previous value, which will store the previous element or the previous number. Long current value, which will store the current number. And finally, what we're going to do is take also some variable, which will store the individual sum of this number. We're going to loop through this less than s dot c. Now when we are taking the length of a string, so we are using double brackets over here, something which most Python or array developers get confused when we work with array. It's not a first bracket open close, but in string it is first bracket open close. And what else? So we have to do this current value. So current equals to s dot char of I, char of I minus. So what is this basically doing? This is basically taking the integer equivalent, or the integer equivalent of the particular character present in that particular string. So one is present as one is present as what? Is present as a character in a particular string. So we have to take the integer equivalent of that character. So we are going to do s dot char of I minus 1 minus 0 plus. Similarly, we are going to do for the rest of the characters. Since this value is going to be, oops, since this value is going to be really long, so we have to divide this entire thing. We have to do the modulus mod plus. We have to also take the previous value into 10, and every time we have to optimize it. So we will use the module, we will take the remainder division of the modulus. So let's check the brackets. I brackets is closing over here, s is closing over here, current is over here, I plus is closing over here, this is closing over here. We are taking also I is closing over here, the particular s is also closing, in previous values num and okay. So the for loop has to be intricately checked. After that, like we have to even calculate the sum. The sum equals to sum plus equals to current. No, we can't write like this because we have to take the modulus again. So current plus sum modulus. Yeah. Once the modulus value is taken, previous equals to current we will store, and after the for loop is done, we will return the sum. The method is closed and the class is closed. Let's compile. Number too large. We can't. Let me check. What we are basically doing over here is we are going to take the modulus value. So I have to check whether this number is accurate or not. So missing a semicolon most probably. cannot find current equals to method caret symbol method caret int s dot caret of I minus 0. Mm, long current. Long current, yes, we have done long current. Long current we have done. Then what? Long current we have done. Also, we have checked the current character is equals to s dot character of I. The string is present dot character present at the ith position. Okay, that is also checked. Minus. So what is the error to say? Method caret location variable is of type string. Variable is of type string. Let's fix this. Yeah. So we can see why is the accepted output not matching. I have to again check. Previous is equals to current. Previous equals to current. Okay. Sum plus current percentage modulus. Oops, a big problem. So it's working now. So let me explain you the code. So in the code, there is like first we are taking the modulus value because it is used for taking modulus in order to avoid integer overflow. Then we have taken the three variables, previous, current, and sum, which are used to keep the track of the previous, current, and sum. And sum stores the final result. Now s dot character of I minus 0 basically converts the character at the index I to its integer equivalent, which I already told you. And I plus 1 represents the length of the current substring being considered. And s dot caret of I minus 0 into I plus 1 calculates the contribution of the particular current character to the substring sum. So in a suppose हमारे पास एक sum है तो उसमें particular character की कितना contribution है. So that is basically calculated using s dot caret of I minus 0 into I plus 1. Lastly, we calculate the contribution of the previous sums by appending the current character to all the previous substrings. So in order to do that, we append करो. How we are appending? So basically we can see we are appending by using plus operator over here. And it's like taking all this previous sum substring sums. Lastly, we are storing the sum equals to current plus like the way we do our basic sum. And previous value equals to current. We always do this so that now the current previous value में जो था वो current बन चुका है. After the loop is complete and all the substrings are added, we will return a sum. And remember, 10 to the power 9 into 10 to the power 9 plus 7 modulus value is important over here. Let's submit our challenge. So we have successfully completed 50 days of Geek for Geeks challenge. And it's a milestone, and we are looking forward to hitting more milestones in future. And feels an amazing part to be sharing this thing on my YouTube. And I also want you guys to achieve your personal milestones and help others with this coding channel as well. Thank you so much, and I love your support for being there for me. Exams are currently going on, but still, it's a wonderful experience to contribute to the people who are coding enthusiasts. And there's always a room for improvement for myself as well. So please feel free to give your feedback in the comment sections.